Thank you all for signing into the webinar, and I trust you're all keeping safe, keeping well. I'm the past chair and current co-chair of the Requirements Working Group. Current chair is Tammy Katz, and myself, Rick Zini, Mike Bryan, Kevin Orr, co-chairs. Currently, there's 584 members, COSI's largest working group. The purpose of the working group is to advance practices, education, theory, requirements, engineering, its relationship to other systems engineering functions. We have the view that requirements are the common thread that ties all the life cycle activities together. Our goal is to expand and promote the body of knowledge of requirements engineering and its benefits within systems engineering community and the scope over all these different areas involved in systems engineering, specifically needs definition and requirements definition, management, verification, validation. Part of expanding, supporting the knowledge base, we have two current products that you can get on the INCOSE store. Our Guide for Writing Requirements, it's about a fourth or fifth revision. At IS 2009, we released the latest version of the Guide for Writing Requirements. Last year, we also published the Integrated Data Foundation System Engineering white paper, and that'll be the topic of this talk. We also are developing some new products, Needs and Requirements Lifecycle Manual, which is the Guide to Verification, Validation, Guide and Managing Requirements. These are all related. The light blue in here just indicates existing documents. The green is the documents that we're developing. The Guide for Writing Requirements currently has some information that's going to be moved to one of the other guides. That's why it has both colors in it. And these are all in work right now, and we're actively developing each of these products. And when they get approved, they'll be put in the INCOSE store for anyone to download. Any members of the Requirements Working Group invited to participate in the review of these documents and comment on them. So we're going to focus on integrated data as the foundation of systems engineering. At IW this year, we received this award from INCOSE for producing this white paper. So we're very honored to have received this award. The white paper was an outgrowth of discussions concerning the working group participation in and collaborating with the MBSE initiative that occurred within RWG during sessions in COSI-IW in 2016 and 17 in Torrance, and subsequent communications between the authors, viewers, members of our working group, and members of other INCOSE working groups. Back in 2016, when the MBSE initiative was just getting started, at the IW, they asked all the working groups in their meetings to discuss how what they were doing relates to the MBSE initiative. And that resulted in this white paper. So goals is to clarify that a data-centric approach to practicing system engineering advocated in the white paper is a major intent of MBSE. Outline the importance for an organization to keep track, manage, and share data and information across all the system lifecycle process activities. They should stay away from the silos and try to knock down all the silos and share information across all lifecycle stages. Provide guidance regarding the management principles and decisions important to implementing and management of system engineering from a data-centric perspective. Provide guidance and tools that can be used to measure and benchmark an organization's capability to practice system engineering from a data-centric perspective, and then present a roadmap to help the organization move toward practicing from data-centric perspective. And the second half of the presentation, I'm going to focus on going through this roadmap. We want to present a broader data-centric perspective of system engineering that's needed for increasingly complex software-centric systems of the 21st century, and provide an integrated view of the various perspectives of MBSE, which can be built upon and expanded on by various INCOSE working groups, tool vendors, and practitioners. The end goal of all of our products is to provide a useful product to help organizations implement the level of system engineering capability that best meets their needs. The intended audience is project managers, system engineers who are stakeholders in any of the activities defined by the system engineering discipline. Any organizations that are thinking about or in the process of implementing system engineering within their organization. There's still a lot of organizations that are producing products that have not implemented the system engineering processes as defined in 15288 in the INCOSE System Engineering Handbook. So if they're thinking about implementing system engineering, this will help them. Wondering how to successfully implement the intent of the MBSE initiative within their organization. Those that are interested in maturing their current capabilities for the more data-centric implementation of system engineering, irrespective of the size and complexity of the systems that the company develops and the size and culture of the organization that's developing the system. The white paper is also targeted to, from a requirements perspective, anyone that's been or currently focused on defining, documenting, and managing requirements as a distinct, separate, siloed activity from other system lifecycle activities, and also some tool vendors who do not currently provide the capability to integrate and share requirements and other system engineering artifacts and underlying data and information across all lifecycle process activities. While these approaches may have worked in the past, may work for some present system development efforts, it's doubtful these approaches will allow organizations to meet the future challenges of increasingly complex software-centric systems. So the key is shareability of data information across all lifecycle stages. So that's a big reason why we produced this white paper is we use a perspective that requirements, which is our real focus, but along with all work products and artifacts, whether you do the model, design activities, developing documents, using diagramming techniques, drawing, developing reports, whatever, that are generated during the performance of system engineering lifecycle process activities, these are all really just visualizations represented by an underlying sets of data and information. And if these sets of data and information need to be accessible and shared across all life cycle stages and between organizations, like a customer and vendor. And also project management and system engineering tools need to share information so it's one integrated view of the project. Project management shouldn't be siloed separately from the system engineering function. Sharing data and information across all lifecycle stages will help to ensure consistency, correctness, completeness of all work products and artifacts, which is a big problem in the document-centric world, where a lot of the documents, as soon as they're baselined and put on configuration control, they're actually out of date. So there really is no single source of truth. And people spend a lot of time and effort managing all these documents when, in a lot of cases, they're not even valid anymore. So project and program managers need to manage projects such that the sets of data that represent all of the different artifacts and work products are represented in the sets of data information that we shared across all system lifecycle stages. If you look at system lifecycles that are defined and you look at all the work products and artifacts, there's a lot of them. And having all these managed as separate entities just isn't going to work. So realizing they're just visualizations of a common set of data information will go a long way in streamlining things and helping ensure that consistency, correctness, and completeness of all the products. There are different perspectives of MBSE. It's interesting to go to organization and they say, we're implementing MBSE. You say, okay, define MBSE to me. And about everybody will have a different definition of MBSE. From the key thing, to some, MBSE is equated to the use of SysML and other language-based modeling tools. Some practice model-based design where they start with a set of design input requirements and ending with developing a set of design output specifications that can provide to those that are going to manufacture or code the system. Others use models to better define their needs and define input requirements and use models across all lifecycle stages. And that's great. That's the focus, of that modeling activity. Another perspective is the goal of MBSE is to move from a document-centric practice of SE to a data-centric practice of SE. So all the models and all the other artifacts are part of that common data system. And so systems are developed and managed using shareable, integrated, federated sets of data. Within the sets of data, all the artifacts generated across all lifecycle stages and the information is linked together. So you have traceability across the whole lifecycle of information. And the result then is a data information model, not only just a system of interest that we're developing, but as well as the processes that we're using to develop that system of interest. So the definition from a data-centric perspective involves formalized application of shareable sets of data to represent all the SE work products, underlying data information generated to support constant maturation, requirements development, design, analysis, and verification validation activities throughout the system lifecycle, from conceptual design to retirement. So using this perspective, integrated, federated, shareable sets of data can be viewed as the foundation of system engineering, and thus the title of the white paper. In the end, as an ideal case, and we're not there yet, but it'd be nice that on the top, all the different activities that are currently done in a lot of organizations, silo, and using different tools, all that data could be integrated and put in this integrated, federated, shareable sets of data. And then on the bottom, all the activities everyone to draw from the data and the sets of data that are integrated. And depending on what they're trying to accomplish, what analysis they're trying to do with the purpose of their activity, then they're working on artifacts and using tools that help them do that. They make a change in one thing, that change will be reflected across all the everything that's traced to it. And this is an ideal case. So the table of contents, section 1, purpose, audience, organization, I kind of went over. Then section 2 goes into the need for systems engineering in general, not model-based system engineering in general, looking to the future. So 2.1 talks about meeting the challenges of increasingly complex systems, and it lists about 10 different challenges. And section 2.2 is benefits of implementing system engineering from a data-centric perspective. So that is about 10 different benefits that are listed for that. And section 3, talk about data-centric perspective. We talk about the engineering work products, that chart that I showed you a little bit ago. We talk about what is a model, and that can be confusing. If you do a word search on model or derivative model in the current system engineering handbook, it occurs over almost 600 times. So the use of the word model is then almost diluted to the point where the meaning is very ambiguous. So we talk about what model-based system engineering is from the different perspectives, go into integrated, federated, shows sets of data, talk about the importance of having a project common ontology, so all the terminology, the relationships of the terms is consistent across all products. As far as databases, having a master schema defined that all the other databases are consistent with, and that helps with the sharing, integrating the data in that respect. And section 3.5 goes through several different versions of data-centric perspective and has a definition. Section 4 goes into some areas that not all system engineers are that familiar with. To go to a data-centric perspective, we talk about success starting at the top. So management, business management, business operations people need to support this concept. Because we're focusing on data and information, the organization is very important to have a data governance policy, and then several cross-cutting process areas defined within INCOSE System Engineering Handbook: information technology management, information management, configuration management. These all need to be focused on. A lot of system engineers focus on the technical processes and not as much on the cross-cutting processes. But it's important that we do this, because if you don't have a foundation of an information technology system, you don't have a way to protecting the data, you're going to have problems. And then the use of measures to better manage system engineering products, both from a project management standpoint and system engineering standpoint. We talk about that. If you go into the INCOSE store, you find at least 5 different products that have been developed concerning measures. One thing that this data-centric perspective does is it really enables projects to better use measures as the intent was in those documents. And then we go into developing shareable sets of data and talk about standards. And John Nayland and some of the different working groups are focusing on developing standards, and there's several different standards out there that are necessary for tool vendors to fully adhere to allow the sharing of the data. Then Section 5 gets into developing a system engineering capability that meets the needs of the organization. We talk about levels of system engineering capability from a data-centric perspective. I know there's other working groups working on modeling capability matrix. The focus of that effort is on modeling specifically, whereas this is talking about data centricity and capabilities that are needed. And I'll go into more detail on that in a minute. Then it's important that you choose the appropriate system engineering tool set that has the features that you need so that you can implement and manage your product from a data-centric perspective, including modeling. And then a lot of organizations question, how do we actually go about making this happen within our organization? So Section 5.3, we address that. Changing cultures that often met with opposition, so we go through some guidance to help address this issue. And then we advocate starting small with a pilot project, and then once you have your processes fine-tuned, your tool set, and so on, and then expanding that to other projects within the organization. So you can get the white paper and read it through, and that's fine the first time you go through it. But the real benefit of the white paper is how can we really use this to help our organizations move to the future so that they can meet the challenges of increasingly complex software-centric systems, moving to a data-centric perspective. To do this, they have to understand what level of capability is most appropriate for their organization, culture, and product line. One size doesn't fit all, and so they need to determine where they want to be and then where they are and get there. And so they can develop a roadmap to achieving this level of capability. So this white paper has the tools built in to help organizations assess their current status concerning challenges and issues they may be currently experiencing due to their current level of system engineering capability from a data-centric perspective, and identify the capability level they'd like to be at. So 7 basic steps that we talk about: getting management buy-in. So success starts at the top. So reading Section 5.3, that guidance that's in there. Understanding the need to do so the challenges and benefits discussed in Section 2. Again, that's the questionnaire in Appendix D we'll talk about. And then in Section 5.1, there's tables at different levels of SCL allow you to assess your organization's current level and then determine the level you'd like to be at your future state. Then organizations need to identify the gaps, develop action plans to make the changes needed to close the gaps, and perform the action plan. Big thing is getting management buy-in. A lot of managers want to see a return on investment from doing this, and so part of your job is to convince management of this. Also, you're going to have co-workers and stuff where, from a cultural standpoint, there's going to be some challenges. That's why we advocate, the pilot project approach, and then start in small flame, and then let the fire spread throughout the organization once you've shown the return on investment for doing this. So this will provide the practical guidance to help management understand the need to transfer their organization to the practice SE from a data-centric perspective. And then understanding the need, like I said, they can read Section 2.2. We developed a questionnaire that's contained in Appendix D. The challenges and the benefits that are in Section 2 have been reworded such that organizations can assess where they are in respect to those. So the questionnaire can do that. A couple weeks ago, I gave this talk to the New England INCOSE chapter, and they took the questionnaire and put it in the SurveyMonkey. But to be successful, organizations have to recognize the need. And so this questionnaire is designed to help them recognize that need. This is a view of the questionnaire itself. I can go through all that, but I'm giving you an idea of the type of questions and stuff that are on there. Basically, when you're going through the questionnaire, you have statements that represent your organization. Then if you have true and mostly true responses, that's an indication you need to maybe think about improving and maturing your system engineering processes from a document-centric approach to a more data-centric approach. So the next step, once you figure out you really have a need, you really want to go forward, management agrees you need to go forward, then we define levels of capability called SCL levels, and those are in Section 5.1. Again, they're in the context of your current level of SE capability in terms of practicing system engineering from a data-centric perspective. In order to do that, there's certain capabilities that you have to have. And so there are 14 factors, attributes that need to be met, or areas of capability that are included in the tables, and these allow you to assess where you are. And your organization may be at different levels for each of the 14 areas of capability. Level 0 is kind of, unfortunately, where a lot of organizations are at. They're still practicing system engineering from 20th century, and they haven't yet moved into the 21st century, even though we're 20 years into it. A lot of silos in the organization. They don't have a data governance policy, process and procedures. They don't really have data management concepts addressed in the project management plan or the STEM. They don't have an integrated management plan. There's no overall ontology and so on. They don't have these capabilities. They're stuck in that 20th century document-centric way of practicing system engineering. Jumping ahead, level 3, the silo project do not exist, or at least they're minimized. There is a data governance plan. There's the information management plans. There's a master ontology, a master schema. They have a tool set that's appropriate for what they want to do, which includes they want the different kinds of modeling, simulation. They have a project management tool set, and both sets of tools are so they can share information between the system engineering side of the house, the project management side, work product, shareability information, traceability, consistency across work products, completeness, use of attributes and measures, and configuration management. And configuration management is big to address organizations. It's really easy, baseline it and put on configuration management, control the changes to it. But integrated data viewpoint, what's really the source of truth and what needs to be configuration management is a set of data that could represent multiple artifacts. So rather than baselining each individual artifact, we baseline the sets of data. And the tool vendors make this really easy. To baseline a set of data, you just remove the write permission. And that is your current source of truth at that point in time. But by doing that, you're ensuring that all the work products that are represented by that data are all consistent in information, which is really key. So then step 4, you go back in those tables and determine where you want to be. You know where you are. You know where your level is to be. And then step 5 is for each of the 14 areas, identify the gap. So you end up going through and assessing where you are, where you want to be, the gaps. And then for each gap, you need to close that gap. And the way you do that is you have an action plan for each of the 14 areas that will result in closing the gaps and achieving the future state that you want to get to based on your specific needs. Read section 4 then to help you develop the action plans. What do you need to do about data governance, information technology, information management, configuration management, defining the ontology, defining the schema. All that information is covered. They'll give you guidance in doing that. And then section 5.2 and appendix C address choose an appropriate SE tool set, features the tool set should have. I hope a lot of you are aware of the work that John Nalen's doing about resurrecting the system engineering tool database. They've been doing a lot of work on that for the last several years. They demonstrated a prototype at IW, and they're continuing to mature that tool. So they're really working hard to help you do this. And then section 7 is implement the action plans for each area, perform the actions that result. Like I say, use the pilot project at first. It's very important that you identify and record metrics. Remember I said earlier, convincing management there's a return on investment for doing this. You're going to get products to market faster, with less defects, higher quality, whatever it is. You need to have metrics so during the pilot project you can show that you are really getting that return on investment. Any issues or lessons learned, you need to document those and then update the processes as needed to go through this. And you can implement the processes for other projects and repeat this whole thing, collecting more metrics, documenting issues, lessons learned, updating the processes as needed for each type of project. Following these 7 steps should result in your organization being able to practice data-centric SE at capability level that meets your organization's specific needs. And so shareable integrated data, we feel is the foundation of all system engineering lifecycle activities. Focuses attention on the shareable integrated sets that underpins everything. You'll end up with a data information model system, the processes. You have generation, visualization, management, all work products from that common set of data, and you're able to use measures to help better manage the project from both project management perspective as well as from a system engineering perspective. Data-centric perspective is essential to manage the system development efforts across all lifecycle, address the challenges of increasingly complex software-centric systems, meet the intent of INCOSE's MBSE initiative and INCOSE's Vision 2025. With that, we're ready for questions. So, Andy?
Hi, Lou. Thanks for a great presentation. I'll now look over the questions that have been posed by the audience. And we have one here. So, audience, this is your opportunity to add questions to the Q&A box. From Paul, how does this initiative integrate with the concept of building information modeling and its maturity levels? Building information modeling, or BIM, also aspires to have a single source of truth for civil engineering assets, and many organizations are implementing CDUs, the common databases, I guess.
I think everything in here is consistent with that whole concept. I know different organizations have different names and terms, but the underlying thing is that you have the integrated data set that ties together and represents all the different artifacts. Key thing is traceability across all life cycles, and that traceability is represented within the data and information model.
So we have a couple of questions, but basically on the same topic. One is the white paper available on INCOSE.org? And the other is, when is the paper being released? Is it already in the INCOSE store?
Yeah, so it was put in the INCOSE store last spring, and so it's available for download. From any INCOSE members can download it for free. I'm not sure non-INCOSE for it, and some products I don't, but it's in the store.
So, question from Mark. How far along are you in developing the information model that you claim is necessary for integrating systems engineering?
There's challenges in that, and a lot of tools were developed to support siloed activities. You may have a SysML tool that allows you to do modeling, but it's not really good at, it doesn't have all the support life cycle. The whole idea about shareability across the life cycle, even if they may develop their own databases, they're putting in provisions for that. At IW19, 2019, we invited people to give presentations on addressing the topic of requirements in the age of MBSE, and we found a lot of solutions to being able to share the data across the life cycles, which is a big part. As far as this common database, I don't know that will ever happen. The tool vendors have their own proprietary methods and so on. In data science, there's concepts like data warehouse, where you can take information, extract, transport, and load different databases into a common database. And if you have a common ontology and schema like we're talking about, that would make that easier. And then you could have tools that would work from that. But I think that's all in work right now. I've seen great progress in assuring that shareability across life cycles.
Then from Sarah, what are some example metrics we can present to management to show that investment will be valuable?
One of the things that happened at IW 2020 and some of the goals that the CAB came up with was addressing doing more verification and validation during the design phase. And so this data-centric perspective, where we're tying all the needs together with the requirements with the design, then developing models of the integrated system, getting to a point you could do simulations, the digital twin concept. You could identify system behaviors and issues during the design phase on the left side of the V, such that on the right side of the V, you won't have all these problems. So part of the metrics you could do is, say, for existing products, we're seeing a lot of rework and issues on the right side of the V during integration. and it's really eating our lunch. So with this more data-centric perspective and moving like verification validation more to the left, then we're going to have less issues on the right side. We're going to be able to get a quality product to market faster. Other metrics that you definitely track would be what's the status of verification validation in general. You have an attribute assigned to the requirements, and you could have dashboards that will allow management to better have insight into all the system engineering activities associated with meeting the needs, validating met the needs, verifying you met the requirements with both the design.
We have a question. What is the scale of investment for moving to data-centric?
It's going to be different for each organization, and depending where you are now, what tool sets you have. I think most organizations probably have pieces in place, just that they haven't really integrated everything together. But everyone has, a tool set. They have to assess the shareability. There are some tools out there developed by different vendors that allow you to link the information from one data to another. So there's going to be an investment in both addressing both people, the processes, and the products, but it's going to be different for each organization.
And a question here is, thank you, I understand the challenge. Does having systems engineering data tied up in diagrams make the problem more difficult?
So the problem is, with that statement, is that the data is not tied up in the diagram. The diagrams are just a visualization of the data and information model. So if I want to look at requirements, a list of requirements, shelf statements, they're going to be in that data information model. If I want to view what the requirements function and I want a functional view, I should be able to just click and I can get a functional diagram. Don't think about the actual artifacts themselves, visualizations. Think about that integrated data set from which they come from, and then that's shareable across any visualization and across life cycles.
There are 2 or 3 questions which relate to difficulty moving to data-centric. And this one, it says, from your experience, what would be the number one reason why some organizations resist moving to data-centric systems engineering? So is it lack of knowledge, risk, management, number of impacted stakeholders involved?
Part of it has to do with perception. So for those who view this specifically testing, especially using system models, really takes a different way of thinking, and it's really confusing to some people. If you take the broader data-centric view, the biggest challenge is culture, and that's why we've done it this way.
To the audience, please, apologies for this. We'll wait for Lou to dial back in because there are some more questions.
Okay, so where were we in questions?
I'm just going to try and get to the point. Yes, it was, in your opinion, what are the main blockers to implementing your data-centric approach? I'm thinking about how difficult and costly it is to integrate tools, and there was a similar one in there, the number one reason why some organizations resist moving to data-centric systems engineering.
The number one is convincing management that there's a need, and we address that. The other is culture, and we address that. The 2 main things. So Section 5.3 was developed specifically because we understand there's going to be some resistance. There's some common questions that management might ask included in the description of Section 5.3 that are typical of different organizations. Culture and return on investment are going to be the main 2 things.
So I've got a question here about tool vendors. Do you see a multi-vendor situation as more beneficial than a one-vendor solution?
Ideally, it would be nice if you could have one tool that did everything. But the truth is the jack of all trades, master of none, really applies. Now, even though SysML has an entity called requirement, it's just a text field. And they have relationships, but it doesn't substitute for the concept of traceability, allocation, and stuff that's managed within a requirement management tool. We have to manage our verification validation. We have to throw in the project management aspects, budgets, and schedules. And there's good tools for each one of those, and there are masters in their area of expertise. So I think we're going to end up with a tool set and a resulting data set. The key is being able to share information then across the different data sets And there's different data science methodologies for doing that. That's, above my head.
As a question, are there specific return on investment factors we should use to sell this idea? This approach will save engineers, product owners, and the analysts a lot of time when researching corporate knowledge. Comments translating this into dollars benefits is the challenge.
Yeah, it is a challenge. Ideally, like for people that have product lines, if they have a digital model of a system with the traceability to everything in that model, and they want to make a revision to that system, they don't have to start from scratch. They have to just go up front, identify what changes are going to be made, and because you have traceability, you can see what the impacts of the changes are throughout the whole life cycle. That's going to save, untold man hours and not having to reinvent the wheel, addressing just what the changes are, what the changes impact, what you have to re-verify, validate to, in that respect. That's going to be a big thing. The other big thing that I was talking about is modeling, allowing us to do more than behavior analysis on the left side of the design rather than waiting to the right side of the V, drastically shorten integration time and cut down costs due to rework dramatically. And I think that's going to be our biggest return on investment is when we get to the level of modeling where we can have, the digital twins so we can assess system behavior. Because the system is the function of the behavior. If you wait until they're in the right side of the V to find out what those behaviors are and emerging properties, you can have a lot of rework. This whole idea of MBSE is going to enable us to do things we couldn't do in the past, and it's going to have a big return on investment because of it.
I think we've run out of time for questions. So thank you again for a great talk, and thank you to the audience for your questions and your time. Lou, could you go to the ending slides, please? So the next slide shows our upcoming schedule. The next webinar will be held on Wednesday, the 15th of April in 2020, when D. Andrew Boy will give a presentation on human systems integration. The following webinar will be held on the 20th of May 2020, when Becky Reed and Ian Presland will give a presentation on how to create a value-added systems engineering management plan. Additional webinars will be offered typically on the third Wednesday of each month through 2020. Please note that if you go to the website shown here, you'll see more information about the webinar series, including a way to view the last 134 webinars and soon this one as well. As mentioned earlier, you can now claim, next slide please, you can now claim 1 PDU credit towards your systems engineering professional recertification by attending this webinar. You may also claim this credit retrospectively from INCOSE webinars that you have attended and where attendance meets the qualification requirements. Please contact INCOSE if you wish to know which webinars you attended and if you met the qualification requirements. Last slide, please. I'd like to again express thanks to Lockheed Martin for sponsoring the 2020 INCOSE webinar program. Thank you again, and goodbye.